Good day, everyone. Good day, Mom. I am Jonathan Grantosa Bertiz with my fellow group mates, Cyril Jane Vidalio and Jer Alosin. We are from BSA33B, and today we're going to discuss data objects, attributes, and basic statistical descriptions of data. So, what are data objects? So data objects or datasets are made of data objects, and a data object represents an entity. Examples: sales database, customer store items sales, medical database. The data objects are patients and treatments. University database, students, professors, and courses. So basically, data objects are the entity in the database, and each entity has a attributes. For example, the entity customer has an attribute of customer name, customer ID, customer address, customer phone number, etc. Those are attributes, but the entity is the data object, which is the customer. Okay? So attribute is a data field representing a characteristic or feature of a data object. For example, customer ID, name, address. Just like I said before, attribute represents an entity or the characteristic of the entity. Okay, for example, like I said earlier, customer name, customer ID, customer address, customer phone number are attributes, and it 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 represents an entity. So there are types of attributes. There are nominal, binary, numeric, quantitative, interval scaled, and ratio scaled. So let's go to the attribute types. So nominal categories states or name of things. Hair color, auburn, for example, auburn black, blonde, brown, gray, red, white. Marital status, occupation, ID numbers, and zip codes. And for the binary, nominal attribute with only two states, 0 and 1. Symmetric binary, both outcomes equally important. So binary has like two choices only. Like in gender, male and female, there are only two choices. And symmetric binary, both outcomes equally important, and asymmetric binary outcomes not equally important, like medical test, positive, negative. Convention assign one to most important outcome. Next is ordinal. Values have a meaningful order or ranking, but magnitude between successive values is not known. For example, grades or army rankings, small, medium, large. Those are example of ordinal. There is a ranking between those attributes. Next is numeric attribute types. Number one, quantity, integer or real valued. Interval, measured on a scale of equal sized units. Values have order, like temperature in Celsius or Fahrenheit, or calendar dates. No true 0 point. And ratio, inherent 0 point, we can speak of values as being an order of magnitude larger than the unit of measurement.
Discrete versus continuous attribute. So, discrete attribute has only a finite or countably infinite set of values. Example, zip codes, profession, or the set of words in a collection of documents. It is sometimes represented as integer variables. Note that binary attributes are a special case of discrete attributes. Next, we have the continuous attribute. It has a real numbers as attribute values. Examples, temperature, height, or weight. It is practically real values can only be measured and represented using finite number of digits. Continuous attributes are typically represented as floating point variables. Next, we have the basic statistical descriptions of data. We have motivation. It is to better understand data, central tendency, variation, and spread. Next is the data dispersion characteristic, median, max, minimum, quantile, outliers, variance, etc. Next is the numerical dimensions corresponds to sorted intervals. So data dispersion, analyzed with multiple granularities of precision, and box plot or quantile analysis on sorted intervals. Next is the dispersion analysis on computed measures. So folding measures into numerical dimensions, box plot or quantile analysis on the transformed cube. Next, we have the measuring the central tendency. We have mean, algebraic measure sample versus population. Note that the small letter n is the sample size and the big letter N is the population size. So weighted arithmetic mean, trimmed mean, chopped extreme values, so this is the formula. Next, we have the median, middle values of odd numbers or values, or average, middle value of if odd number of values, or average of the middle two values otherwise. So estimated by interpolation for group data. So we have this formula. Next, we have the mode, value that occurs most frequently in the data. Unimodal, bimodal, trimodal. So the empirical formula is mean minus mode is equals to 3x mean minus median. Next, we have the measuring the dispersion of data. So quartiles, outliers, and box plots. Quartiles: Q1 25th percentile, Q3 75th percentile, inner quartile. IQR is equals to Q3 minus Q1, 5 number summary, minimum Q1, median Q3, and box. Box plot. Ends of the box are the quartiles. Median is marked. Add whiskers and plot outliers individually. Next, outlier. Usually a value higher or lower than 1.5 times IQR. Variance and standard deviation. Sample S, population is the median. So variance, algebraic scalable computation. So this is the formula. Then the standard deviation S, or mean, is the square root of the variance of S squared, or mean squared. Next, we have the graphic displays of basic statistical description. We have the box plot, graphic display of 5 number summary. Next is histogram. X-axis are values, Y-axis represents frequencies. Next is the quantile plot. Each value xi is paired with fi, indicating the approximately 100 fi% of data that is less than or equal to xi. Quantile minus quantile, or Q minus Q plot, graphs the quantiles of one univariate distribution against the corresponding quantiles of another. Lastly, we have the scatter plot. Each pair of values is a pair of coordinates and plotted as points in the plane.
Now let's discuss about the graphic displays of basic statistical descriptions. Let's start with the box plot analysis. Box plot analysis consists of 5 number summary of distribution, which are minimum, quartile 1, median, quartile 3, and maximum. The data in box plot analysis is represented with a box. The ends of the box are at the first and third quartiles. The height of the box is IQR. The median is marked by a line within the box. Whiskers are the 2 lines outside the box extended to minimum and maximum. Outliers are the points beyond a specified outlier threshold, plotted individually. Now let's talk about the histogram analysis. A histogram is a graph display of tabulated frequencies shown as bars. It shows what proportion of cases fall into each of several categories. Differs from a bar chart in that it is the area of the bar that denotes the value, not the height as in bar charts, a crucial distinction when the categories are not of uniform width. The categories are usually specified as non-overlapping intervals of some variable. The categories or bars must be adjacent. Next is the quantile plot. It displays all of the data, allowing the users to assess both the overall behavior and unusual occurrences. Plots of the quantile information. For example, in the image below, for a data X, data sorted in increasing order indicates that approximately 100% of the data are below or equal to the value of X. Next is quantile to quantile plot. Graphs the quantiles of one univariate distribution against the corresponding quantiles of another. Example, shows unit prices of items sold at branch 1 versus branch 2. For each quantile, unit prices of items sold at branch 1 tend to be lower than those at branch 2. And last graphic displays of basic statistical description is the scatter plot. It provides a first look of bivariate data to see clusters of points, outliers, and etc. Each pair of values is treated as a pair of coordinates and plotted as points in the plane.